Okay, welcome back to the concept check to review your answers. This is number 3, and for number 3, we're given the problem of finding the y-intercept, the x-intercept, the line of symmetry in vertex, and that's all for this equation right here. And we need to show all the work that goes with our problem to lead to our answers. So, first of all, we want to find the y-intercept. Well, remember in any quadratic equation, your first term is called your quadratic term. And that is because it's a term that's to the second degree. So that's called your quadratic term. Of course, the pen is not writing really well, but we'll see if we can get this out. So this is quadratic term. The next term is called the linear term. That's because that's a term that's a degree 1 term. So your first was a degree 2 term, which gave you a quadratic term. Second was a degree 1 term, which gave you a linear term. And then last but not least is called your constant term. And this term has a degree of 0. Okay, so it's called your constant term. Another reason it's called your constant term is because it never changes. In this case, it's -1. That term will never take on another value. It's always going to be -1. Whereas your linear term will take on other values. It's 4x. So the linear term is going to change depending upon what x equals. So if x was 1, your linear term would equal 4. If x was 2, your linear term would equal 8. It's always changing. Whereas the -1, the constant term, is always going to be -1. In order to find your y-intercept, we need to remember that the y-intercept happens along your y-axis. So let's go ahead and label our axes here. Graphing was not part of the question, but it's always helpful. So here's your y-axis, and here's your x-axis. And your y-intercept is going to happen anywhere the graph crosses the y-axis. In other words, it's going to intercept the y-axis. And all along that axis, x equals 0. So if I was to put numbers in here, this is 0, 1, 2, 3, 4, 5. So all along your y-axis, x equals 0. So in this case, we're looking for what does y equal when x equals 0. So I'm just going to plug a 0 in for all those x's. So I have y equals 2 times 0 squared plus 4 times 0 minus 1. This equals a -1. It's going to equal your constant term. And the reason is because that's the only one that's not going to change regardless of what x is. Here, x is 0, so your quadratic term goes away, and your linear term goes away, so you're just left with -1. So your y-intercept is going to be when x equals 0, y equals a -1. So if I was going to plot that on my graph, of course giving a scale here, so I'll just go by ones. That would be right here. And I'll just do that in pink so it's very obvious. Okay, so that's -1. Now, we need to find our x-intercepts. And at this point, finding our x-intercepts, I'm going to kind of rewrite the equation down here. I have y equals 2x squared plus 4x minus 1. So at this point, in order to find our x-intercepts, I'm just going to kind of focus on what happens with these two terms. And then I'm going to shift it according to the y-intercept. So here, I'm going to kind of rewrite my equation. I'm just going to kind of call it y1 because it's not really the same equation as the first one. I'm going to write 2x squared plus 4x. And then I'm going to, this is an expanded form, so we're going to want to factor it. So remember what goes into the first term and the second term. I have a 2x. So when 2x squared is divided by 2x, I'm left with x. When 4x is divided by 2x, I'm left with a 2. Now for intercepts, I need to figure out what is going to cause my whole thing to be 0. Because along my x-intercepts, and I'm going to just kind of put a little highlight here, that's when along the x-axis, when it intercepts the x-axis. And along the x-axis is when y equals 0. So we need to figure out when y equals 0. So here, what causes this first term to equal 0? Well, in order to get a 0 here, x would have to equal 0. For my second term, in order to get a 0 in this second term, x would have to equal -2, because -2 plus 2 equals 0. And remember, the only way to get a 0 is multiplying by 0. Okay? So far, if my equation didn't have that -1, my x-intercepts would have been 0, 0, and -2, 0. Okay, so it would have been 0, 0, and -2, 0. But since I had a y-intercept of -1, that means that everything goes down 1. So everything gets shifted by 1. So now my x-intercepts are not going to be -2, 0, and 0, 0. It's going to be something maybe a little off to the side, because all those points got shifted down because the y-intercept shifts everything down. But what the x-intercepts do help us with is finding our line of symmetry. And we know that line of symmetry is going to happen right here in the middle of the x-intercepts, because that's where our equation can fold over on itself. So I know the line of symmetry is going to happen right here at x equals -1. And I know that along the line of symmetry, somewhere along there is going to be my vertex. In order to find my vertex, I need to figure out what y value is when x equals -1. So I have y equals 2 times -1 squared plus 4 times -1 minus 1. So let's see here, what does that equal? So -1 times -1 is a positive 1, so it's a 2. 4 times -1 is a -4 minus 1, so that equals a -3. So I know that I'm going to get a -1, -3. So my vertex is right there. So I have a -1, -3 for my vertex. And here's my line of symmetry. Just to make sure I got my answers clear. So when I go ahead and draw this out, I have a parabola that looks sort of like this. Now, at this point, notice that your x-intercepts are a little to the left of that -1, 0, and a little to the right. So we're not sure at this point exactly what they are, so we're just going to go ahead and estimate. And here I'm going to just put in that we're estimating. And I'm going to say, well, it's a little smaller than a -1, so I'm going to put -1.2, 0. And it's a little bit bigger than 0, so I'm going to put maybe a 0.2. This is just an estimate, and it's a close enough, so it's good. In the next section, we're going to learn how to find those exactly by factoring. So as a little preview, remember your x-intercepts are also called your solutions. And that's what we're going to find in the next unit. So this was number 3.